Hello, my name is Melis and our topic is diabetes prediction using machine learning algorithms, and I will present introduction, dataset, and literature review. Next.
My name is Mustafa. In this presentation, I will tell you about the exploratory data analysis and methods parts of our work.
And I am Eray. I will present results and discussion part and conclusion part. Also, I will present the codes.
Next. Diabetes mellitus was chosen for this research because it is a very important disease and many people suffer from it. Diabetes is a serious chronic disease that occurs when sugar levels are high in the blood for a long time. Glucose needs insulin to move throughout the bloodstream. Insulin is a hormone produced by the pancreas that regulates blood sugar. Next. If the body has a problem producing insulin, glucose cannot enter the blood cells. The aim of this study is to determine whether people have diabetes or not. This problem is a classification problem. The method used in this paper is supervised learning. This method is often used for chronic diabetes. The algorithms used in the method section will be presented in more detail. Next. The data set used in the study is a frequently used dataset. It is necessary to train algorithms and measure their accuracy. It was found appropriate to use the PIMA Indian diabetes database for this. Next. The database has 8 attributes. These are pregnancies, glucose, blood pressure, skin thickness, insulin, body mass index, DPF, age, and outcome. For machine learning training, the dataset should be divided into 2 parts. One part should be the training part and the other part should be the testing part. The model is always adapted to the training set first. In the test part, performance measurement is required. Next. In the study, literature review was conducted and studies using the PIMA dataset were found. In one found these studies, SVM, naive bias, and decision trees were used. The highest accuracy rate obtained in the study was stated in 76%. In a study using another dataset, logistic regression, KMN, naive bias, begging, etc., comparisons were made using algorithms. Next. In the study, the highest accuracy rate of 96% was obtained with the logistic regression method. In other study, 75% accuracy was obtained with AMM. Next.
In the study, different exploratory data analysis methods were used. Firstly, the missing values were found. After that, the distribution of the patients in the data. Next, please. Missing values were replaced with means. Afterwards, detailed statistics of diabetics and not diabetics patients were obtained. Next, please. Histograms of the features were obtained and they were interpreted in a more meaningful way. Then a correlation matrix was obtained to describe their relationship with each other. Here, the relationship of some features with each other were not. Finally, normalization was performed for easy learning. Next, please. 5 algorithms were determined for the methods parts of the study. These are naive Bayes theorem, support vector machines, KNN algorithm, decision trees, and adaptive boosting classifier. Naive Bayes approach is commonly used in supervised learning classification that is linear. It's been shown to be effective in text processing and document classification in the past. The probabilistic character of this algorithm is well known. The support vector machine algorithm is distinguish the data by creating a hyperplane with respect to the distinct dimensions. Next, please. Kenan is a comparatively simple. The Kieran method posts the closest point to the point to be predicted and classifies it based on the majority class in the neighboring points. One of the major drawbacks of the approach is the categorization of outliers and the difference in classification when the value of k is changed. Decision trees are machine learning commonly used machine learning method that makes predictions by asking a series of questions. Depending on the answers to each question, the algorithm decides which path or branch to take next until it reaches a conclusion. And finally, adaptive boosting classifier, a statistical classification method that adjusts its weights by combining weak rules with more of erroneous predictions given larger weights. As a boosting classifier, it works in tandem with their algorithms that have performed poorly in their prediction task and is used to improve accuracy. Next.
Results and discussion. The results of all the implemented classifiers are here. In order to tune the hyperparameters of the classifiers, optimized hyperparameters input were used in the model function. After training the previously discussed algorithms on the datasets with a ratio of training and testing of 0.8 and 0.2 respectively, the following results were obtained for each algorithm. As you can see, support vector machines and decision trees has low scores, F1 scores and accuracy scores, but naive Bayes, KNN, and ensemble learning has very high accuracy and F1 score, especially KNN algorithm has 0.99, which is very close to 1. Also, confusion matrices are extracted. False negatives are important values to minimize for disease prediction models, since patients who have diabetes are labeled healthy incorrectly. As indicated here, KNN, ensemble, and naive Bayes algorithms produced 0, 6, and 5 false negatives respectively. Therefore, these models are designed to use for diabetes prediction. And here, optimized hyperparameters are shown in tables for each model. 5 machine learning algorithms were used to predict diabetes. 778 participants were included in the investigation. Having used the optimized hyperparameters, a maximum accuracy of 0.99 was achieved by the KNN among the other algorithms. In EDAPART, outlier removal, replacing zeros with mean, and min-max scaling are used to get better accuracy. But when these methods are applied in the datasets, accuracy drops to around 0.65 in optimal. So outlier removal and replacing zeros with mean decrease the efficiency of the learning process. Therefore, data is just normalized as indicated before. Now let's look at the code. Firstly, we have loaded the data and we set the randomness. Then we have separated data to diabetes and healthy and bring together. Now box plots for healthy and diabetes data have extracted, like we have seen. And then correlation matrices are computed to see correlations between features. Age and pregnancies have a lot of correlation, and skin thickness, insulin also. Then we have to pre-process the data. We have used many methods, but they reduce our learning accuracy. So we have decided to use normalization technique, and we had to do it by dividing every feature by its maximum values. Then we create model. We have separated X and I. and training is 80% and test data is 20% separated like that. Then we fit a model. We use ensemble, SVM3, Naive-Bayes, KNN. And also we use optimized hyperparameters to get better accuracy, to get the optimal accuracy. Then we evaluate the model confusion metrics. And we computed the accuracies, F1 scores, recalls by the benefit of this built-in function, stats of measure. As you can see, these results are extracted for the report. That's all.